The goal of this first part of the tutorial is to create the master sketch, pretty much this center line and these red radial lines. Okay, but before that we are going to start a new ISO assembly and right away save it to our work directory as spiral casing assembly and hit save. Okay, so the next step is to create a sketch, of course. So in the home tab, move to the sketch panel and select the sketch tool. Make sure the coincident plane option is active on the command bar and select the ZX plane. Now we can start sketching. So we want the origin to be the center of our spiral casing, so everything will go from this point. To create this, we will start by creating these red lines. If you zoom in, you will see that the lines are all coming from the origin and are angularly spaced 20 degrees apart from each other. We will start with this line. So move to the throw panel and select the line tool and make sure you click on the origin. The length should be 685,5, then enter, and then for the angle we will enter -20, and you can see the line is created. So we right click to finish this line, but the line tool will stay active. Okay, so we can go on like that and create the other one. So back to the origin, then we enter the length, which is now this 675, then the angle -40, enter, again the origin, and the next one, which is at 660, and this time we will enter -60 degrees, and okay, so we'll stop there and we will add some dimension, and then I will show you a different way to do this. So to dimension the line, we will use the smart dimension tool. Select the line and drag it. There we have our length dimension, again for this one and for this one. Okay, now to create the angle, again go to the dimension panel and select angle between. Okay, we need to select the dimension origin element. We will select the x-axis, and then the measurement element, we will select this line and drag away. So we have our angle created. To close the dialog box which appears, just right click. Okay, and again we are prompt to select the origin element. So you select this one as the origin element and this one as the measurement element. Okay, and then right click to close the box. Origin element, this one, measurement element, this one. Okay, as you can see, we now have these 3 lines done. Okay, another way to do this is to copy this geometry using a revolve tool. I'm going to show you that right now. Okay, so we will just move to this tool. Here you have the move tool, and underneath the move tool, if you click the black triangle, you have the rotate tool. This will help us duplicate the geometry because the angle is basically the same, make sure that you have this button highlighted so that the copy option is active, and then change this step to 20 degrees. And now we are prompt to select element to modify. We will use this line, then we will select the center of rotation as the origin, and the point to rotate from, we will say this endpoint. Now we have to define the angle of rotation. Okay, so because we enter 20 degrees as the step, each time we will rotate 20 degrees from the origin element, we will snap, as you can see. Okay, so we just click to place the first line, then click, then click, then click, then click, 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 and click, and to finish, right click and escape. As you can see, we have the remaining lines in place, but it is not over yet. If, for example, we grab this line and move it, it will not move away, and this is because this angle and this dimension fully define the line. If you have been using other software, you know that when an entity is fully defined, his color change. Okay, to make Solid Edge behave the same way, all you have to do is to move to this inspect tab and select relationship color. As you can see, these three lines are black. That means that they are fully defined, but the other ones are still blue. That means that they are not fully defined. And if I grab this one and move away, you see it is not constrained, so we have to constrain it. And to do that, let's go back to the Home tab. We will come to this Relate panel and select the Connect tool. Now we can zoom and select the endpoint of each of these lines and snap it to the origin. As you can see, this will be a very difficult and tedious task. So the better way to do that is, let me undo. The better way to do that is to go back to the Relate panel and then select Relationship Assistant. The Relationship Assistant will create the constraint, the connect constraint between the endpoint of all these lines automatically for us, and it will also add the dimensions provided that we have the correct settings. So we are going to make sure that we have this place geometric relationships selected and this key point connect ticked also, and we will place dimension, and those will be the length of the lines. So okay, and then we can select the lines we want to constrain together. I don't know if we can select the origin. Not. Okay, so right click to accept, and as you can see, all the linear dimension are created, and if I try to drag this, it still move around, but as you can see, all the lines are connected. So now what we have to do is to use the connect tool, select one of the endpoints and snap it to the origin, and there it is. Now if we try to move this line, as you can see, it will just rotate. That means that only angular dimension are missing. Once again, we are going to use the angle between to create them, and we will select this as the origin element, and then we will click on the next line and place the dimension. If you remember, the last time we did this, we right click to close the input box, but this time what we are going to do is to move directly to the next element and select it. Why we can do that? Because here you have in the front bar, click the dimension measurement element. That means that it is not necessary to close this every time. So move directly to the next, select it, click to place the dimension, again click to place, again click to place, again click to place, and you see this is a very quick way to do multiple dimension in one shot. Then we place it again, and there it is. All the lines are now black. That means that they are fully defined. So what we are left to do is to enter the proper value for all these angles. We could just go around and enter each time 20 degrees, but this is not a very robust way of working, because if later in the design we decide to change this angle from 20 degrees to, let's say, 15 degrees, we will have to go back in the sketch and change all these value to 15 degrees. So this is not a very robust way to do this. So what we are going to do is to link all these values to this first value, and to do that you could either right click and select edit formula, and this edit formula command bar will appear. Then what you have to do is to select the dimension you want to be the driving dimension, for instance this one, and here you have basically a formula saying that this dimension will be equal to this other dimension, and then you right click to finish. The second way to access the edit formula dimension is to double click on a dimension. As you can see, the edit formula toolbar appear, and then left click the dimension and right click to finish. Okay, I found that double clicking is much faster than right click and edit formula. As you can see, it can be pretty fast, and you don't have to look anything, just double click, select the driving dimension, right click, zoom from time to time. So as you can see, this is very fast, and there it is. The last step is to change the length of these lines to the final values. So this one is already okay. Now we'll move to this one, which should be 644,5, then 630,5, then this one 614,5, then this one 596,5, 578,7, 558, 533,5. Now I will use the middle button of the mouse and shift key to pan the view so I can select the other dimension and zoom in. Okay, so this one is not, this one is 533, 5. Then we have 533, 5, 507, 5, 476, 435, 377, 3, 311, 5, and that's it. Seems like I have one extra line, so I will select it and delete it, and as you can see, all these lines become blue. That means that they are no longer fully constrained, and that is because when I add the connect constraint earlier, I select the line, just delete. So we are going to move this away and again select the connect, reach the endpoint of the line and connect it again. Hopefully this will be the last time. We should have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, up to this one, it is 15. Okay, now we have to add this line, which is just an horizontal line. Maybe we will not add it right now, but we will add this one. Use the line tool and just create a line like that, and again another line which represents the inlet, this top part. Now we will create this dimension using the dimension tool from the x-axis to this line, and the value should be 900. Okay, so this diameter is 700, so I will enter the value 700, and we should have a dimension from this line to this one. I don't know the value yet because, as you can see, the PDF drawing is cropped. I checked the finished model and I found that the value was 731. So we are going to add this distance from the Z axis, if I can select that. Okay, let's say from the okay, the smart dimension is not quite working, so we are going to use the distance between, and we are going to make sure that we have this horizontal and vertical. We are going to select the midpoint of this line, and we are going to select any endpoint and drag it, and then we call in 721. Okay, so as you can see, these two lines are equal. We are going to use the equal relationship. This one and this one are equal, and then they are in a vertical alignment. So we could use a horizontal vertical constraint between the midpoint and the midpoint. Okay, and the next thing to do is to add this dimension, which is 538. So smart dimension, this line and this line, we have 538, and everything is pretty much in place for our center line. Okay, so select align tool again, from the midpoint to the midpoint to the endpoint, endpoint, endpoint again, make sure you snap to the endpoint. Okay, and one, but we're not going to stop there. We're going to add a little line to finish with. You will see his purpose later. Okay, so we have our center line, which is looking more like a spiral, and pretty much good so far. And let's check if we have constrained everything as they should. So we can change this value, for instance, to 30 degrees, and nope. Okay, so let's see, 22 for instance. Okay, 22 is working. If you decrease the value, if we pause here for a second and have a look on this line, we will see that it is way longer than it should be, and the reason for that is this dimension is maintained as an horizontal dimension instead of the length of the line. So because this line was horizontal when we created the dimension using this relationship assistant, the dimension was created as an horizontal dimension. So this is why we are having this trouble. So we will delete this dimension, then using the smart dimension create a new one and input back the value. So now the shape is more like it should be. Let's see how it is working now. So increase, seems fine. Let's see if we can pass 30 degrees without any problem, and back to 20 degrees. Okay, so the lesson here is that you should always test if the sketch you made is behaving as it should. Okay, so let's try this one too. No problem. And that's it for this part. For the next part, we will be adding more and more details, and we will find a way to manage all these dimensions, because as you can see, it is very difficult to select things with all this dimension on this line. We'll see that in the next part. Okay, see you then, and thanks for watching.